Hello. I think we are live. Live and in living color. All right. Wait to see everything get started. Make sure I'm not going crazy with my internet, all that kind of good stuff. Get rolling here. There we go. There we go. It sounds like we got good sound. Sounds like we got good video. Woohoo! Starting off great. Starting off great. How's it going? How's it going? How's it going? How's it going? For those of you joining me live or on demand, I hope you all had a good weekend. Today is May the 11th. We are in May, May the 11th. May the 11th. Hello, hello, yes. Hello, hi. How is it going? How's it going? How's it going? Get started here in just a second. Just a second here. Just kind of making sure the bat symbol goes up and the people that are up here and ready to get on can get in and be able to and be able to join us that are wanting to go live here. So yes, hi, yes, I'm hiding my hands here. Got all my markers and all that kind of good stuff here. So hope everybody who is here had a good weekend. Had a good weekend. I'm going to talk a little exponents here. Yes, I know exponents on a Monday morning is totally fun to talk about, but we'll get through that. We'll talk about it a little bit. With the time permitting on there, I will go through the packet here for those questions about exponents, which conveniently is topic number 3. There we go. Topic number 3. I hope that it's the word for it would be kind of a easy way, you know, easy to kind of figure out with that. I hope. Yes, happy. Thanks. Oh my. Um, I hope, like I said, I hope it's more of a review. If it is, great. If it's not, well, here we go. Again, I'm going to get right into this. I'm going to talk about exponents. Exponents. What do we use exponents for? What do we use exponents for? So, what do we use exponents for? Yeah. So if I had a get it right, and I'm going to provide you with a little bit of a scenario here. So we have this little bacteria cell. We have this little bacteria cell that we see right here. This little bacteria cell divides every 20 minutes. Every 20 minutes to make two cells. And the question that it asks you here, it says, well, how many cells will there be after 1 hour? Okay. Obviously, if it if it if it if it divides every 20 minutes, there are going to be 3 segments in that hour, right? So there's 3 segments. Yes, I do. So there are. So here's what I want to kind of go over here with the whole exponent part here. If we're breaking this down, well, let's start. Let me rewind here a little bit. So if we have this expression, the expression 2 times 2 times 2 again, that will represent the number of cells after 1 hour if there is one cell at the start. The question it asks you, it says, how can you write this expression using exponents? So how can you write this expression that I'm underlining right here using exponents? Okay. And the question it'll say is, how many cells will there be after 1 hour? Well, we tell you that in 20 minutes. So how many 20-minute segments are in 1 hour? There's 3. There's 3 of them in 1 hour. So if it splits to get you two cells after 20 minutes, you're with that base of 2. And again, like you see right here, it gets multiplied 3 separate times. So here's my question for you, or more kind of a statement. We use the exponent. We use an exponent to show repeated multiplication of a number. We can sit here, we consider whether or not whether or not you are in, sixth grade, seventh grade, or eighth grade, or ninth grade, 10th grade, or whatever. If I sat here and I said, well, what's 4 times 4 times 4 times 4 times 4 times 4? Okay, there's an easier way to write that. There's an easier way to write this whole kit and caboodle right here. There's an easier way that we can write all this. There's an easier way that we can that we can write all that. We have to sit there and say, well, how many times is 4 being multiplied in a row? And you see that we have 1, 2, 3, 4, 5, and 6. So if we have 1, 2, 3, 4, 5, and 6, 4 is being multiplied 6 times. So the repeated multiplication is 4 raised to 6 as our exponent. Now here's what I'm going to kind of break it into a little bit of vocab here. The 4 that you have right here, is what's called the base. It's what's called the base of what you're trying to do here. The 6 is actually the exponent. Now, a lot of us, when we say things, we like to say, well, 4 is raised to the power of 6. 3 is raised to the power of 2. The actual vocabulary term on this, the actual vocabulary term of power in this instance, power, let me get rid of this. Power is the whole entire thing. The whole entire thing is actually considered to be power. It's almost like you're saying you're giving the number 4 here. You're giving the number 4 superpowers. If you think about it, that's kind of a way to it's kind of a way to sit there and say, well, to kind of delineate the different vocabulary that you have right here. So like 4 raised to the 6 as an exponent there. That's actually the proper terminology of the way to say that. Yeah, Dimitri, that's 7-3. I said it in my upload last week with that. I When I had uploaded a recent, like I think it was the 7th grade video, I used something that was in there, and it gave this whole copyright claim on the YouTube channel. So I scrapped that. I mentioned that in that upload from last week, but yeah, this I'm focusing on just these lessons, and I'm going to go through those questions at the end right there. So again, that's I'm just not going to risk getting the channel something happening to that. So hope that makes sense. So again, 4 raised to the 6 is the power on this. Okay, so then again, 6 is the exponent, and the number 4 is your base. So in this instance, let's clear all this now. So if we have an expression of 2 times 2 times 2 on that, we can call that 2 raised to the 3rd. It's 2 multiplied 3 times. 2 multiplied 3 times. Okay, so the next part of this, if I were to tell you, then there's this term of saying, well, what would that actually be? Well, how many cells will there be? Well, we have to evaluate this. If we evaluate this expression that we see right here, yes, I'm holding my cup right here. So if we evaluate this expression right here, we can take 2 times 2 times 2. 2 times 2 is 4, and then times 2 would be the number 8. Okay, how many cells would there be after 1 hour? That would be 8. 8 cells. 8 cells. Okay? Kind of keep moving here a little bit. So then in this, if you say, well, there are 2 times 2 times 2 times 2 times 2 times 2 times 2 times, and you can read bacteria cells after 3 hours. Write the repeated multiplication as a power, and there's what I was talking about with saying the difference between saying it, writing it as a power, and then evaluate this. You're basically counting up how many times you see 2 multiplied here. So in this instance, we see there's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that would be 2 to the 9th power on this. So that's 2 to the 9th power on this. So just for the sake of argument, I can do this on here. 2 to the 9th power. 2 to the 9th power. I'm doing it on my other one here. 9th. 2 raised to the 9th power, I don't know if you can see this or not, is actually 512. So if we were to evaluate this exponent, if we were to evaluate that exponent right there, if we were to evaluate that exponent, how many cells after 3 hours? It would be 512. 512. This is why can you represent the number of cells after 2 hours as the power of 2 to the 6th. 2 to the 6th, well, if in our scenario we have that cell breaking down 3 times in 1 hour, 3 times in 1 hour, how many times is it breaking down in 2 hours? You know that it's going to be 6 in 2 hours, so 2 times 2. I think you guys get the gist of what I'm talking about here. Okay. You know, I saw even Steven when I went to the school recently, and even Steven was crying in the corner. No, I'm just kidding. I don't know if it's still sitting up on the projector or not, but yes, yes. Let's move. Let's move. And again, I hope a lot of this is kind of like more of a review-ish type thing. But the question here is, how can you evaluate 2 to the 0 power? Okay, 2 to the 0 power. Now, this is what the reason they do it this way is to show you the rule of what 2 to the 0 actually, anything raised to a 0 power, or sorry, raised to a 0 exponent. So I'm even using that terminology. If you look at this and you say the base is 2, the exponent is 0, the exponent of 0. So make a table. It says make a table, look for a pattern. 2 raised to the first power. Well, anything raised to the power of 1 is whatever that base is. So if you see 2 to the second is 2 times 2. 2 raised to the third power. 2 raised to the third power is 2 times 2 times 2. 2 raised to the fourth power is going to be 2 times 2 times 2 times 2. So as you can kind of see what happens here, 2 to the fourth evaluates to 16. When you evaluate it, it ends up being 16. If you lower that exponent by 1, it cuts it in half. If you lower the exponent by 1, it cuts it in half. It cuts this value in half, right? So when you lower that exponent, it cuts that value in half. So again, if you lower the exponent, it cuts that value in half. How can you evaluate 2 raised to a 0 power or anything raised to a 0 exponent? 2 raised to a 0 exponent is simply the number 1. Anything raised to a 0 power is the number 1. Is the number 1. The number 1. All right. So and then you'll see right here, multiply by 2. And like we say, I work backwards. You see that it gets cut in half, cut in half, cut in half, and cut in half. Okay. So like if I were just to kind of take you a little bit further, if I said, well, what's 2 raised to the negative 1 power? 2 raised to the negative 1 power, what would that be? Well, what would happen if you cut 1 in half? If I cut 1 in half, what would that be? It'd be 1/2. Anything, and this is just kind of moving kind of into more of an more of an 8th grade rule right here, but anything raised to a negative power actually flips it into a fraction like this. So if we were to continue this table right here and say 2 raised to the negative 1 power, the value that it would evaluate to would actually be 1/2. And as you see, it continues with that cutting in half, cutting in half, cutting in half, cutting in half right there. Okay. What's up, James? Hey, what's up, man? Again, any non-zero number, raised to an exponent of 0 has a value. All right. All right. So, and your and what was it? It was Apple Bits or I can't. Oh my god. So if I were to evaluate 1.2 raised to the four exponent on there, or if you were to take this and say, well, this is 1.2 raised to the fourth. So again, 1.2 times 1.2 times 1.2 times 1.2. Okay. If I were to simply just put 1.2 and multiply it 4 times, you will see that. And it just breaks it down right here, that 1.2 to the fourth will actually go to be 2.0736. I think it was blue alphabets, I believe, right? All right. Try one more here. Try one more. A couple more, I should say. But so if I were to evaluate 1/3 raised to the third, remember this. If you were to multiply this out, 1/3 raised to the third is simply 1/3 times 1/3 times 1/3. That's if you were to write the repeated multiplication. So now if you were to evaluate, remember when we multiply fractions, we multiply from left to right. We multiply from left to right here. Okay. 1 times 1 times 1 is obviously 1. 3 times 3 is 9. So 3 times 3 is 9. 9 times 3 will be 27. So when we evaluate 1/3 raised to the third, it's going to be 127. If you see what happens, like when you raise fractions, when you raise fractions to an exponent, you see what happens to that fraction. That fraction gets smaller and smaller and smaller and smaller. All right. So what's up, Lucas? How you doing? How you doing? Hope y'all are doing good. I hope y'all are doing good. We're, like I said, we're May 11th right now, so kind of chugging right along with new this new normal, right? Kind of interesting stuff. But alpha blue, alpha blue. So last one here, and I'll get into those questions here. Julia calculated the foil as 1.9 times 10 to the fifth units thick. Why she calculates that as 1.9 times 10 to the fifth, I don't know. So, Tom, interesting. I'll start calling people Tom calculated the foil as 183,000 units thick. Which calculation represents the greater thickness for the foil? Well, if I were you, if I was given this kind of a question and I had 1.9 times 10 to the fifth, or if I had 183,000, you got to, and this is what I'm going to talk about a little bit later with another grade level, 8th grade. I'm going to be talking about scientific scientific notation with this. If you have one of these, this right here is in scientific notation. This is in scientific notation. write that notation. And this is in standard form. This is in standard form. If we're comparing two values, we have to make both of them one value. Like you either bring the one that's in standard form to being into scientific form, or vice versa in this instance. Now, from what we know as sixth graders or whomever, 1.9 times 10 to the fifth. 10 to the fifth, 10 to the fifth is 10 times 10 5 times. So 10 times 10 times 10 times 10 times 10, right? So 10 to the fifth right here is 100,000. If I take 1.9 times 1.9 times 100,000 in that instance, if I take 1.9 times 100, my YouTube went down. There we go. There, hopefully it catches up. If I take 1.9 times my 100,000, so now if I were to evaluate this final part, 1.9 times that 100,000 would give me 190,000. It would give me 190,000. So which calculation represents the greater thickness for the foil? Well, it would be Miss Julia's. Julia's calculation was the thicker thickness. If that's the right way of saying that. Hope that makes a little bit of sense. Let me take a few minutes, go through some of those questions from the packet there. Clear this off, get this down. Okay. Again, if you have this with me, or if you're with me on this, I'm on topic 3, holding up 6 fingers for some reason. Topic 3, so that's lesson 3.1. I talk about understanding and representing exponents. So, like we had just talked with this, if we were to write each expression, remember, this right here is an expression. Write that expression using an exponent. How many times do you see 8 multiplied in this instance? So you say in this, well, how many times do you see 8 multiplied? And it's 1, 2, 3, 4, 5, 6, 7. If 8 is being multiplied 7 times, I'm taking that base of 8 and I'm putting it to an exponent. I'm raising it to an exponent of 7 to writing it using that exponent there. Okay, so 8 is our base, 7 is our exponent, and the entire thing is called power. Okay, all right. So your answer is 8 to the 7th. 8 to the 7th. 8 to the 7th. There you go. 8 to the 7th. So number 2, we just see just a plain old 4 there, right? Well, how many times is 4 being multiplied? 1, right? 4 to the first power. Anything raised, and this is anything raised to a power of 1 is whatever that base is. So if I have 300 raised to a power raised to an exponent of 1, simply put, when you evaluate it, it's just going to be whatever that base is right there. Okay, it's going to be, it's going to be 300 right there. But in this instance, if I write this expression using an exponent, it's simply just 4 to the 1, 4 to the first. That's the way to kind of say that. Number 3, if you have 10 multiplied 4 times, so if I have 10 multiplied 4 separate times, the number that's getting multiplied is going to be our base. So our base of 10, in this instance, raised to an exponent of how many times is it being multiplied? Well, you see it as 1, you see it as 2, you see it as 3, and you see it as 4 times. So 10 raised to the 4th. 10 to the 4th would be your expression using that exponent. Okay. And I hope that this next part is kind of simple, just because we just took a good amount of time going over this. But now we would want to evaluate the expression. Number 4, I'm going to move sort of up here with this. So if I have 9 to the 2nd That means it's simply 9 times 9, right? So it means 9 multiplied 2 times. 9 times 9 is simply put just 81. Okay? I'm going to move quick, but for number 5, if I have 99 raised to the first, 99 raised to the first is simply put just 99. It's just 99 on that because it's just using it one time. It's whatever the base is. Number 6, and it tells you right here, if you don't remember for some reason, we used that little table earlier when we did the table to cut down what each exponent would evaluate to there. So if I have 3,105 raised to the 0, anything raised to the 0 is simply just number 1 on that. Is always, always, always equal to 1. Any number with an exponent of 0 is always equal to 1. Number 7, 22 to the second is 22 times 22. And just because my mind isn't working too much right now, 22 times 22 is 484. 484. Okay. And number 8, you have 2 to the 7th. So if I have 2 to the 7th, it's 2 times 2 times 2 times 2 times 2 times 2 times 2. It's 2 multiplied 7 times. 4, 5, 6, 7 would be 100. Would be 128. 128. All right. And finally, 3 to the 4th. 3 to the 4th is 3 times 3 times 3 times 3. 3 raised to the 4th is 3 multiplied 4 times. If you have it on your calculator, you can do it this way. But just for my instance, I'm just going to go 3 times 3 times 3 times 3 is 81. Hope that makes sense, guys. That's exponents. We'll talk a little bit more about evaluating expressions tomorrow. Hope that helps a little bit. Those of you who are going to join me a little bit later, I'll see you a little bit later. If you have any questions, please shoot me an email, shoot me a Google Classroom, whatnot type thing. I'm more than happy to help. All right. Other than that, I hope you all have a good day. Talk to you soon.